Welcome students. In this video, another application of Bernoulli's equation is explained, and that is called Pitot Tube. So Pitot Tube is a device which is used for measuring the velocity of flow at any point in a pipe or a channel. So the principle behind Pitot Tube is that the velocity of flow when a point it becomes zero, the kinetic energy possessed by the fluid is converted into pressure energy. So we can see an example here. So in the figure you can see a tube which is bent at right angles. So this is the tube which is bent at right angles. Okay, and fluid is flowing through this tube. The direction of fluid flow is given, and when the fluid reaches this point, the velocity becomes zero and the liquid rises up. So at this point what happens is that the kinetic energy is converted into pressure energy. So if we consider 2 points 1 and 2 at the same level, point 1 is here, point 2 is here. So point 2 is the inlet of the tube, which is the Pitot tube. So P1, V1 are the intensity of pressure and velocity at section 1, and P2, V2 are intensity of pressure and velocity at point 2. H is the depth of liquid in the tube, that is capital H, and small h is the rise of liquid above the free surface. So depth of liquid under the surface is capital H and rise of liquid above the surface is small h. So applying Bernoulli's equation at points 1 and 2, we get the equation P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Here 1 and 2 are points which are on the same level. So Z1 is equal to Z2. So those terms get cancelled. And also we know that when the fluid enters the Pitot tube, velocity becomes zero. So V2 is equal to 0. So one more term is cancelled. So P1 by rho g is the pressure head at section 1, which is capital H, and P2 by rho g is the pressure head at 2, which is H plus capital H. That is, at point 1 the head is only this much, but at point 2 the kinetic energy is converted into pressure energy, so the head is larger, capital H plus small h. So substituting these values, the equation changes to capital H plus V1 square by 2g, which is equal to small h plus capital H. So from that equation we can derive V1 is equal to square root of 2gh. This is the formula for theoretical velocity, which we already know, and actual velocity is given by CV multiplied by theoretical velocity, or square root of 2gh. So CV is the coefficient of Pitot tube. So velocity at any point is given by V is equal to CV multiplied by square root of 2gh. Next is the velocity of flow in a pipe by Pitot tube. So to find out the velocity at any point, some arrangements can be adopted. First one is that Pitot tube along with a vertical piezometer tube as shown in figure 6.14. So in this figure you can see that there is a Pitot tube. Pitot tube is a tube which is bent at right angles. So along with this tube there is a piezometer tube to measure the head. Okay. Again in 6.15 we have Pitot tube which is connected with the piezometer tube. See, here it is connected in a different way, like a U-tube. Third one is Pitot tube and vertical piezometer tube connected with a differential U-tube manometer. So it is shown in figure 6.16. So you can see a U-tube which is here, which is connected to the Pitot tube. Okay. And again in case 4, which is figure 6.17, there are two circular concentric tubes, one inside the other, with some annular space in between. The outlet of these two tubes are connected to the manometer. There is a differential manometer which is used to measure the pressure head. So in this figure you can see two concentric tubes, which is this one and this one. Okay, so these two tubes are connected to the differential manometer, which is this one, which is used to measure the pressure head. So we have seen the 4 cases where a Pitot tube can be used to measure the velocity. In the first 2 cases, the Pitot tube was connected to piezometers. In the third case, the Pitot tube was connected to a U-tube manometer. In the fourth case, the Pitot tube and the U-tube manometer or the differential manometer were connected to two circular concentric tubes. So let's see a problem. A pitted static tube placed in the center of a 300 mm pipeline has one orifice pointing upstream and other perpendicular to it. The mean velocity in the pipe is 0.8 of the central velocity. Find the discharge through the pipe if the pressure difference between the two orifices is 60 mm of water. Take the coefficient of Pitot tube as Cv is equal to 0.98. So the details given in the question are the diameter of the pipe, which is 300 mm or 0.3 meters. Difference of pressure head is given as 60 mm or 0.06 meters of water. Coefficient of Pitot tube is given as 0.98, and also the mean velocity is also given, which is 0.8 of the central velocity, that is 0.8 times central velocity. So central velocity is given by the equation Cv into square root of 2gh, which is the equation for actual velocity. So we know the quantities Cv and h, which can be substituted to find out velocity as 1.063 meters per second. So mean velocity is given as 0.8 times the central velocity, and it comes to 0.8504 meters per second. Discharge Q is given by the equation area into velocity. So area is the circular cross-sectional area and V here is the mean velocity, which is found out from the central velocity, which is otherwise the actual velocity. So this answer for discharge comes to 0.06 meter cube per second. Next, a Pitot tube is inserted in a pipe of 300 mm diameter. The static pressure in pipe is 100 mm of mercury. The stagnation pressure at the center of the pipe are recorded by the Pitot tube is 0.981 newtons per centimeter square. Calculate the rate of flow of water through pipe if the mean velocity of flow is 0.85 times the central velocity. Take Cv is equal to 0.98. So H, or the difference in pressure head, is given by stagnation pressure head minus static pressure head. So that is 1 minus 1.36. This is given as 2.36 meters of water. So velocity at the center is given by the equation for actual velocity, which is CV multiplied by square root of 2gh, which is equal to 6.668 meters per second. Mean velocity is 0.85 times the central velocity. Okay, so the rate of flow of water can be obtained by multiplying the mean velocity with the area of the pipe, and that comes to 0.4006 meter cube per second.